Okay, great. Hi, I'm Rosie, and I'm from Biosciences, and we've been working with Sakara and have some very exciting things to share. So just to set the stage, kind of the question or the story that a lot of people have is we have some sort of sample, we're going to sequence that sample, and now we need to do analysis on it, and why do we need to do that? We need an answer for whatever question it is. So this is obviously clinical, could be plant, could be agriculture, whatever, very, very generic problem there. But sample to answer is what people always really want. You don't really care about sequencing, you care about your question that you're trying to answer. So our sequencing machines, they put out base call files, binary files. No one really knows how to read these if you're not really experienced in that area. So that needs to be turned into something that is readable. In order to do that, you have to take your data off the sequencer, you have to put it somewhere, you have to know where it is, you have to be able to view that, explore it, give it to people, spread it around. And then you actually have to do that conversion into that readable format. And that's a FASTQ file, which is kind of the most common file that people are using right now. And that goes into a lot of secondary analysis. So if you get a FASTQ file, your world is opened up, especially to a lot of pipelines as well. So how do we get this story from sample to answer out there? Well, there's a lot of problems and questions along the way. So how do I get affordable but high quality data? That's number one, you need to get your data sequenced. Once you have it, where do I put this data? Cloud, local, do I need to buy something? Do I need to pay cloud costs? I'm not sure. How do I run a pipeline? And how do I do it automatically? Because it's usually not scalable to have one person just sitting down and doing everything, especially once you get a whole bunch of samples or you're growing your program. Well, same question with secondary analysis. I've got my FASTQ files, but now I want to get to those great answers. I have clinical insights or something else. How do I do it? Where do I do it? Which pipeline do I choose? Do I build my own? Is there a great open source one that I can already use? And then, keeping going with that theme, how do I make this as automatic and scalable as possible? And the cloud is a really great solution for this, but that is also scary to some people who haven't necessarily had a lot of experience in it yet. How do I learn these things? How do I get involved in it? What do I not know that I need to know? And then after all of that, you kind of have to ask, if you're a small team, do I have somebody who knows this already, or do I have to make them learn how to do this? Or maybe I can't have somebody do it yet, so how can I get that set up? And those all lead to bigger questions in the long run, like once you have this set up, how do I do QC? How do I start to route all this data together in different ways? How do I make it scalable and reproducible? Both really important, especially when you're talking about moving into something like a clinical application. It's kind of overwhelming for some people, but we've got some answers to this. So first of all, let's start with sequencing. We have the Aviti machine at Biosciences, and this is where sequencing can start with high quality data at an affordable price. So the data has very good accuracy, over 90% Q scores, over Q30, well into the Q40 and above range sometimes too. The instrument has two sides, so you can run dual flow cells, one on each side, also flexible start, so you can start something on Monday, wait, do something on Tuesday, do them at the same time too, with 1 billion reads per flow cell. So you can get a lot of data out of it, but also it's tunable. So we have several different kits. If you don't need 1 billion reads, you can go a little bit lower, go a little bit faster. If you don't need 150 cycles, we've got 2x75 and 2x300 kits as well, so you can really bring your application to it. We have our library preps as well, Elevate, but also Adept, which is compatible with over 65 different existing assays. So if you're using it, you can probably integrate it into your current flow. And the nice bit here is that at the end of the day, you have a really affordable cost per gigabyte or cost per read. Okay, so let's just talk a little bit of data behind that. So Aviti produces high quality data. Most of the Q scores are over Q40. So if you look at this chart, you can see that that green is well weighted in the 40 to 45 area. And if we look at those Q scores, these are against truth data sets, so we know it and can say, here's what we predicted versus here's what is known. It's very well calibrated, and they fall right on that line that you see indicating that there. This is all explained in this paper, so the QR code is there. The link is at the end of this presentation as well. Go check it out. The data is in there, and there's also some data on long inserts, and it's all on truth data sets so that we can know what it is. So I would encourage you to go check that out. Here's just one other example with some of the long insert work that was done there. So this is PCR-free whole genome sequencing at 2x150, 35x, and HG1 to 4 chorial samples, the NIST truth data set for benchmarking. So what we're seeing here is that there is a low number of errors. As you get those long inserts, 500 to 1,000 base pairs, you can see a trend downward each way, so you're able to rescue a little bit of data and get better coverage. So the FASTQ data for all 8 of these runs is also public in that data set. You can check it out and try and reproduce it yourself. All right, so you've got high quality data. What happens for your next step? So this is where Elembio Cloud with Element comes into the picture, where we start to make these connections for people. First thing is that you get remote run monitoring. So if you look on the left here, that's going to play and give us a little view of what this platform looks like for people. So, while it's sequencing, you can get a view of what's going on. You can even plan a run ahead of time, work with some LIMS systems. Cloud storage, bring your own if you want. You can use an Element hosted bucket if you want. That data is going to stream up into the cloud. You'll get a nice view of the data in our interface. And of course, your primary analysis metrics to view and say, how good is the sequencing run? And it's going to explore in-depth Q-scores, error rate, indexing if you have it, and give you a venue to do that. Now, the most important part here is that next step. How do we then connect that to an analysis partner ecosystem and make it simple and easy for people as well? So I'll just skip forward to this for a little bit. You can see kind of the end of a run story here is when I get to those data files. I've got these raw sequencing files. What happens next? So we already solved this problem before, and this is a solution that was presented a couple years ago to say, here's how to automate your data. So coming off of a VD, there's a final file that gets written, a run uploaded.json file. You can write an object listener on Amazon if you're using Amazon for that. Say, hey, I found that file. Now go and do something in a Lambda to kick it off with the right authentication and code that can reach out to Nextflow Tower and get your data for you. That is a good solution. That definitely still works. If you have questions about the details of it, talk to Edmund. He knows all about it. It's really flexible, so you can put this on any system. Or if you have an existing pipeline, it works really well. You might need to integrate something in. So this works and is still very viable. But there's some cons. It's a little bit of a manual setup, so it's not necessarily templated out. You have to go and learn how to do that. And again, if you're maybe a person that doesn't yet know this, you need to learn about AWS infrastructure. And that's not always the easiest for everybody, especially if it's, say, your first time getting into that. And then also, it's a repeated infrastructure setup. So let's say you have like 4 or 5 customers and they all do it and you find a problem. You now have to tell all of them to solve the same problem several times, which can sometimes be a little bit frustrating for everyone involved. So we had some ideas about how to make that process a little bit better for everyone. And that is working with Elembio Cloud and integrating it with a platform like Sakara to centralize some of those steps to be a little bit reproducible. So same situation, the Aviti instrument can always stream to your cloud of choice, AWS, Google, Element, whatever you need. But at the end of the run, there's going to be a run completed event that comes to the event queue. And that's going to set up a workflow trigger. So you do have to configure your workflow, which I'll show you next. But once that workflow triggers with an authenticated protocol, it can reach out to your Sakara platform and launch that workflow. So in the case of what we've done, we prototyped with a basis to FASTQ Nextflow that is not yet public, but I hope it will be one day. It's really simple. It's just a wrapper on our basis to FASTQ. This is already in Nextflow core, so you can also use it there, but this was just one that we could prototype with a little bit faster without having to worry about impacting anything. Once that is done, you get your nice data files, and again, that can stream to your cloud of choice. AWS, Google, Element. If you're a person that's providing data to somebody else, you can even send it directly to them. You don't necessarily have to build a protocol to like redistribute this data in some way. So what does that actually look like? So on the left here, you'll see Elembio Cloud. We're big on explaining things to people, because again, maybe everybody doesn't know anything, but you get a simple form where you can connect to your Sakara platform through an authenticated token. And that's going to need to have the permissions to let you launch, so that does have to be set up. But once it is, you can say, great, we're connected to that platform. And then you can set up your flow configuration to basis to FastQ. So you can see that on the right here. And it's a pretty simple model. You have some input locations that are those cloud storages. You have some output locations that are cloud storages. And then you can set up a trigger to either be manual or automatic. So automatic is obviously what most people want, but sometimes you need to turn it manual, especially if you're prototyping or changing something. And then in terms of the platform, that actually looks like this in Elembio Cloud. So we do a light reporting to say, here's what was executed automatically. You can always see that, but really that data belongs in Sakara platform. So you can monitor the workflow just to, if you were looking at your run, you're looking at your primary analysis, and then it kicks off. You can say, here's how it's going, but the deep stats and everything that are in Sakara that are awesome are still in there, and you can connect to that. You can also relaunch your workflow. You can do it in either platform too. If you do it from the Elembio Cloud, you'll keep all of your connections to all of that original run data, just so that if you are comparing like primary analysis to after, or maybe in between different runs, it's going to be able to collect that for you. But full data visibility here. So it's really, leveraging each platform's benefit, but not trying to redo anything. So here's just a little bit more information about how that looks. So on the left here, once you get your completed run dial, you have this directory of base calls that you get there. Then we have this kind of platform automation magic that we've described here. You can go check your completed run in Sakara. That's awesome, but the real magic here is on the right, where you just sit and let this happen. It's set and forget once it's configured, so you don't have to be manually doing anything in order to have this set up. So just some summary points here. Elembio Cloud, what it's really helping you do is leverage automation so that you can get to that hands-free goal for that first step of FastQ analysis via event-based actions. So not relying on the file, but relying on events that you can replay, retry, and also expand into different actions in the future. Really importantly as well, this goes to your cloud storage of choice. So very flexible ecosystem to use wherever you need your data to go. It's your platform as well in Sakara. You're just connecting them together. The really nice thing I love about Sakara is it's great, it's easy. If you aren't an AWS aficionado, there's great things like Tower Forge that will set it up for you. They work really well, really easily. So effectively, with a few clicks, you can get this system set up rather than potentially a few weeks of learning if this is new to you. And then setting up your flow, you have that connected automation from that run complete event that you can reuse as many times as you want to continue and relaunch that data. Obviously, you want it perfect the first time, but we all mess up our indexes sometimes, right? So what's next in this? Secondary analysis. Just like we described for this, that's a whole nother problem. Is it a run model? Is it a sample model? Is it both? Is there metadata you need to start tracking? Is metadata uniform across everyone? Answer, never. Everybody has custom metadata. So how do you deal with those questions? We've solved this internally. We have an internal database, and we've done very well with setting it up with Sakara for our pipelines into different things. And we'd like to look at that and say, how do we generalize that? Especially because there are resources like NF Core. So really valuable resources that if you can plug them in easily, we'd love to enable that automation and just letting people string it together without having to do as much work. And the very exciting thing is early access of this is opening February 2024. So if you're interested in a VD or something like this, or this is a problem you're struggling with, please talk to me, and I can get you some resources to get into that. So here's an example of how we at Element have done it. So here you can see that this is our pipeline where we have a whole bunch of different outputs. We've got our alignments, we've got CMPs, we've got everything. And the way to do that is we're aggregating some of our samples, doing our internal magic that we're hoping to generalize, we launch our whole genome Nextflow workflow on Sakara. And then again, we just sit and wait. So this is really nice because someone says, I need a run, and I say, okay, great, I'll call you back in a day when all the sequencing done and our analysis pipeline is completed. So looking to figure out how to share that experience with other people as well. And lastly, just acknowledgements. I'm here presenting this data, but there's a large team behind it who makes a lot of different stuff happen. So thanks really to them because they've done the bulk of this work. Yeah, that's it. So if you have any questions, we can talk about those now. And again, if you have any interest, please let me know.
Thanks so much, Rosie. I'm really excited to see where you go with the next steps of this, particularly related to the metadata. Also something we're thinking about a lot with regards to having registry, linking that data back to the analysis itself, as well as the downstream steps in that. We've got a couple of questions. One is around, have you thought about integrating something like BBMap Clumpify, which is really around compression of those FASTQ files, or are you when you're basically transferring them up into cloud? Are they in some
it's usually pretty fast, so I would say that's not an issue that we observe often. The whole workflow, it's about 30 cents and 30 minutes on the image size that we have. If you don't want to spend 30 cents, you can spend $1 and it'll be an hour. Okay. So it's really like, it's cost of return.
Yeah, amazing. Edmund's been typing a question for a while. No? Okay. Okay. Awesome. Well, thanks a lot, Rosie. And we're going to have a break now. There should be coffee and the like around. So thanks a lot.
Thank you.